the Baltic Blue Accelerator. This is our ambitions to kind of pitch the future of marine ocean materials. I just need to have this one as well. My name is Peter Vangsbo. I'm the director of ARP in Denmark. I'm spearheading our initiative on how we can convert blue biomass into low carbon construction. And people are thinking, hey, what is it and how does it look like? This is an example from Denmark. It's a very well-known museum where they have made used coastal straw as a facade component as roof cover. This is just an example on how we can utilize these type of coastal zone and marine products. This is not new. In Denmark, we actually have a very small island away from any forest, and when they were building their houses, they were not they were struggling to get enough of material to use roof cover, so they start to use eelgrass as roof cover. And every year they put more roof cover, more eelgrass as roof cover. And what is really interesting with this experiment, it's still standing. These houses are still there. We have around 18 of them. Every time we go around on a tour, the tour guide, he will take a lighter at the end of the tour and try to ignite the roof cover. This eelgrass, because it has so much brine in it, it cannot burn. Some of the proposition that we are extracting from the marine environment is very, very unique and can actually help us a lot to push the use of marine bio-based material. So that inspired me a lot, and thanks to Nordic Innovation, Arab, and a whole bunch of Nordic actors were joining forces in an alliance to create a technical handbook on marine bio-based building materials. We identified around 30 products, which are shown in this publication. And it was launched for nearly a year ago. And the momentum of this journey is now taking a next step, because we are going to explore where can we actually grow this blue biomass? How much can we grow? What can we grow? How is the weather, the climate going to change the growth pattern? Is there actually a huge marine regenerative potential when we are intensifying the growth of blue biomass? Can this blue biomass actually extract the nutrition from our environment? Can it actually give life back to the fishing community? In the Baltic Sea, we see that the cod are really shrinking a lot. It's shrinking because it cannot find food. If we have this idea that we can try to intensify the growth of blue biomass and actually help the marine ecosystem, take a lot away of the nutrition, the carbon, and use the built environment as an archive for this material. This is the great thought we are having, and end of February we will have the first national roadmap, if that will be possible, and we will explore how much existing building materials can we actually substitute with these new type of products. So this is why you are here today. You are actually helping me to identify what is possible from researchers and existing architect companies. How can we actually think together to push this? In order to push it, we need investment. So today we have an extraordinary jury. They are all in the front line. We have my colleague Sarina, which are working with Earthshot Prize. We have Emil from Nordic Innovation, and we have Morten from Blue Bornholm, an NGO which are exploring ocean marine labs. And then online we have Carl Bakstad from White Architect, International Director for White Architect. We have Victoria Boros from VC Compass. VC Compass is the investment arm of a large window manufacturing from Denmark called Velux. And then we have Tilde Holm from Upstream Partner, one of the most progressive real estate developer in Denmark. From the mother organization is called Alpha Development, and Tilde is working in the arm called Upstream Partners. And with us today, we have here in the room a few of the presenters. We have Carmen, and we have our UCL team, and we have Bjarne from his studio, Studio Hammer. And I actually think we should start with hearing a little bit about Nordic innovation and Emil's push on blue economy. So Emil, join me at the stage. And because I have been, had some IT difficulties, I will have to reduce your presentation with a few minutes. So I will give you 5 minutes if it's okay.
That's okay.
To present Nordic innovation and your push on marine economy.
Okay.
Thank you.
Thank you so much. Thank you, Peter, and thank you for inviting me. So my name is Emil Geroth, and I'd like to begin by putting something to you, which is that if you are a business looking to do business that has to do with the ocean, then the Nordic region, this region, is a pretty good place to be. Ever since the days of the Vikings, we've been living by and with the sea, although happily today in more peaceful ways. We have very strong marine sectors and a lot of know-how and a lot of innovation capabilities and a lot of capital markets in this region that we can use to sort of boost the marine sectors. But there's more that we can do. There's more that we can do, and if we can cooperate with each other, then there's lots to be gained. And that's what we're trying to achieve in Nordic Innovation. And for those of you who don't know us, we are an institution under the Nordic Council of Ministers, which means the official cooperation body between the 5 Nordic governments. And our job is to help Nordic businesses to connect with each other and work together to become more sustainable and innovative and competitive on global markets, but also to open up the Nordic region for international investments and international solutions and help us become more of a cohesive player on the international stage. And for the past several years, we've had a sustainable ocean economy initiative where we've, among other things, have looked quite a bit at the segment of marine biomass and things that you can do with that that might be surprising. And so as part of that, we supported the report that Ora put together on marine building materials. And we've also supported a number of different projects looking to use things like seaweed and algae and oyster shells in new and surprising ways. And this is something that we are going to continue to do. And because we see a lot of potential in this sector and in supporting the marine sectors in the Nordic region and beyond. So I'm very excited for that reason to be here and to hear about all the solutions that you've got prepared. And I'm looking forward to the day ahead.
And then Emil, you also have funding opportunities coming up.
That's true. We have a big open call for proposals coming up in the autumn. We haven't published it yet, but it will be published in September, October. So do keep an eye out for that if you're a Nordic business looking for funding.
And I've been working with Nordic innovation over the last few years, and if you want to search for a fantastic holistic partner which are really connecting the whole supply chain, then Nordic innovation is a very agile innovation arm of the Nordic Council of Ministries and are fantastic to work with. So keep an eye on on Nordic innovation and the good work that you're doing across the Nordic. Thank you so much, Emil.
Thank you.
And let's give Emil a hand. And another initiative which I would really like to share with you is that we have the founder of Blå Bornholm, Morten, present here today. And Morten is also having an invitation to you. Perhaps it's not funded related like Emil, but more partnership orientated. So Morten, share a few words on the Baltic Blue Innovation Community.
Yes. Thank you very much, Peter, and thank you very much to Arup for hosting this event, which I'm very pleased to be a part of. As Peter said, my name is Morten Ledertov, and I'm from Denmark, representing the NGO association called Blue Bornholm. And we are a NGO located, as the name says, on Bornholm, in the middle of the Baltic Sea, just below Sweden. So we are an association trying to strengthen the work within the communities of initiatives and young actors working with developing new blue value chains in the Baltic Sea region. We are right now working along with Arup and actually funded by Nordic Ministers, Council of Ministers, sorry about that, along with the Danish Technological Institute and other partners, local partners and around the Baltic Sea, in bringing initiatives together in a form of hackathon. And we are trying to create a new work model where we can share knowledge across and find new ways to create and strengthen these often complex value chains needed to be built around new initiatives within this field. Therefore, I would also like to, as Peter said, invite you to Bornholm. Right now we are still planning and finding out all the logistics, so I can't give you a concrete date right now, but reach out and we will invite you to one of our first hacks, where we will try to see what kind of collaborations we can create across borders and who can work together in strengthening their initiatives. So very grassrooty, trying to build up this new economy.
And Morten, if you should just put like 2 words on the hack, what is it that you're trying to hack?
We are trying to hack how to create value of these streams that are often seen has low incomes in different ways, and also strengthening the way that you source your base product, because we don't want to harvest just cutting down the sea. Most of our initiatives that we're working with, they actually take something that is seen as a problem around different areas in the Baltic Sea and turning that into new products. So a very sustainable way of sourcing, but that's also very complicated. So we need to have better understanding on how to source and who can help us source all around the Baltic Sea region.
And specific on marine blue biomass again.
Exactly.
Yes.
That's what we're working with.
Good.
Blue biomass.
Perfect. Good to know, Morten. And I think this is also a kind of an innovation model where we can bring the entire supply chain together. As you can see here, we have some very important actors which can actually bring it into life, especially the offshore center Bornholm. For you who are not familiar with our geography here in the Nordic, then Bornholm is a very small island, but not an insignificant island. It's really an important island, especially for our future energy infrastructure. In Denmark, we are planning to produce 200% of offshore wind, or produce 200% renewable energy by installing offshore installation. This huge investment push will open doors for a lot of blue biomass production area near to the offshore wind farms. So we have some really powerful collaboration partners here. And again, it's the money who will drive this innovation push on blue biomass. So we are really, really happy with this setup, and I have big hopes for your hackathon. I look forward to participate, Morten.
Thank you for having me.
Thank you. So now it's time for our pitches. And what we will do, I will give 5 minutes exactly to each of the solution provider. Then we will have our jury to give a little bit of feedback, ask questions to the individual solution provider. So it will be a pitch, 5-minute pitch, and 4-minute QA from our jury. And I would like to bring you, Carmen Kennedy. You have come all the way from Brisbane to present to this. So thank you so much for your commitment. I'm really looking forward to hear your 5 minutes pitch. I will give you this one. And then I will have a different feature on my phone. I will actually have a decibel measurement. So when you are clapping, I will be able to actually see how much of commitment the audience will give your solution. So I will start my countdown, 5 minutes now.
Hi everyone, and thank you, Peter, for having me. I'm Carmen Kenny. I'm the founder of Mineral Fox. We're based in Australia, and we were founded in 2020. Our Circular Sea collection is a range of lime-based wall finishes that are made from recycled oyster shell. They're a blue biomass circular finish and a comparative with conventional wall finishes in terms of performance and durability. We have different aesthetic finishes from colour, texture, and aggregate size. And the shells themselves are 96% calcium carbonate, so the same composition as limestone, which means that we can substitute the limestone with the recycled shell. We've completed or are in the process of completing some very large-scale, high-profile commercial projects. The Parramatta Powerhouse Museum in Sydney has over 10,000 square metres of recycled oyster shell render. And Arup's Brisbane office was completed earlier this year. We have the potential to replace plastic and cement-based wall finishes in both commercial and residential settings. We have developed a render with the oyster shell already and are working on our proprietary formulation for a finishing plaster. And our end goal is to come up with a paint that is comparable to plastic paints. Our finishes have low embodied carbon, and the oysters themselves sequester carbon as they grow their shell. Then we, as Peter was saying, archive that in the building material. We have huge potential to scale this globally. Every year, more than 10 million tonnes of oyster shell waste is dumped in landfill and in our oceans globally. We're providing a circular end-of-life solution, reducing the strain on landfill. We're partnering with NGOs who are working on oyster reef restoration projects, and we dovetail into their supply chain. So we sponsor their work, and they collect additional shell waste from restaurants and seafood wholesalers. And perhaps even more exciting, now we're getting large-scale export companies contacting us to give them an end of life for their waste. Oysters are excellent water filters, and they take nutrients out of the sea. An adult oyster can filter up to 190 litres of water per day. We're creating local jobs through our NGO partners who collect, clean and deliver the shell to us. And we're providing an important end-of-life solution for the oyster industry, which provides an important source of low-carbon protein for people around the world. When we combine this with the potential of seaweed and algae polymers, we have an even greater potential for regeneration. And our end goal is to work towards avoiding mineral extraction of limestone and sands altogether. We've recently received a significant government grant from the Australian government to set up a world-first circular manufacturing facility. And our first phase is to export our products globally, with phase 2 working with local partners who can source our raw materials locally. We have a view to expand the range beyond oyster shell to include blue mussels, seaweeds, and expand our range of finishes for both the residential and commercial space. This is a world first. We've invested significant R&D to date. We have our proprietary formulations and exclusive supply contracts. Our ask today is not for financial investment, but for partnerships and collaboration. If you were here, Carl and Tilda, I'd be looking at you, but I would ask for support for us to have some large-scale commercial projects here in the Nordics and perhaps in Europe, specifically 5 by the end of next year, to help us raise the awareness of these materials and their potential. We're also looking to establish local go-to-market partners and research partners in the areas of biopolymers and ask for financial investment in phase 2. Thank you very much for your time. Thank you, Peter.
Good.
Good?
It's no. You have to. You just have to stay.
Questions. All
Thank
right.
you so much, Carmen. Very impressive presentation. But I'm not to judge. The jury are to judge, and I will need to bring you up to the stage for each of the presenter. So I will step down of this stage, and then we will have Emil to start, then Serena and Morten. And then we will take the jury online. So super quickly, Emil, 2 punchline back to Carmen.
Yeah, I think this is very interesting. What I'd like to hear more about is the long-term business model for this. So obviously you're trying to compete with traditional wool finishes now and then traditional paints later on. Do you expect to be competing on price or performance or both? That's something I'd like to hear more about.
Just a short answer.
Price will come. So at the moment, it's more expensive than your conventional paints, but the right clients will pay for it. And as we scale and we get more advanced with our process, the price will come down, especially because this is waste material.
Serena?
My question for you was why the Nordics? You manufacture in Australia. I presume that you have to ship over to the Nordics. Is there capability to manufacture locally, depending on where you source the material?
Yeah, that is my goal, because touching on this worldwide problem of the waste, my intention would be to set up, whether it's licensing or franchising, the ability to make these materials locally. And why the Nordics? Because this area is leading the world.
Good. Morten?
I was also wanted to touch up on how you would source from the Nordic and how that would affect the sustainability aspect of the product. But let me touch on, how do you feel that with your business you could influence policy making into pushing regulations towards having your products more present in bids for government buildings and so on?
Yeah, I probably need some help with it, to be honest, Morten. We're finding in Australia that government clients are really asking for this, and there's a really strong remit to use more of these bio-based materials. I don't know what the landscape is here in Nordics, but that's why I'm here to ask for some help.
Perfect, and I can hear a lady screaming for help. So Tilde Holm online from Denmark. I hope that you can hear us. Could you just give us a shout if you can speak up? Tilde is not here, but then I know that Carl Bakstad from White Architect. Carl, can we hear you?
Yes, I hope so. I can hear you. Can you hear me? Yes. Okay.
Perfect. We can hear you. Carl, did you also heard that a lady in need need some help. Carl,
Yes.
is that white architect who could
I hope
explore
so.
that?
And I'm very happy to when hearing you saying that the Nordics are leading on a few things. We will have to keep that spirit up, and I think it's very important. And of course, it's events like this, you know, with sharing of the experiences. Definitely, I think that. I mean, I was also curious on how to make this a local production out of this, because that is, I guess, needed. But further on this. Regenerative approach that you have, I think that is something that we should also bring more into the policy discussion into that, because that is only in the beginning, I would say. So my advice is that that should be addressed even more, and then also happy to guide you then into some contexts here.
Thank you. Thank you,
Great.
Carl.
Thank you so much, Carl, and thank you so much, Carmen. Thank you for the jury. We will have to take the next pitch, so you can all sit down. And I just need to look at Joachim, who the next speaker will be. Is it online? Perfect. So we have another amazing startup company from the UK, Pretender. I hope that you can hear us. I can see you definitely.
Hi, Peter.
And I hope that we can bring your slide on the screen.
Hi, Peter. I cannot unfortunately share my screen. I do not have the share request on the platform.
Good. Then you just have to present without your slide, and I will count down in for your 5-minute presentation.
Yeah. Is it possible for the host to allow me to share the screen if possible? It's on the Zoom link. I've sent the request here. Or I'm happy to otherwise just present.
Let me see, Joachim. We will just give it a few moments. Perhaps Carl Bakstad, could you give just a little bit of introduction to White Architect and why you are part of this jury and find blue biomass interesting? Carl?
Yes, of course. Yeah, I mean, White, I mean, a Swedish architect firm, now also working in the UK and in Germany with offices, but of course interested to share experiences from the Nordics, but also learning from other parts of the world. And then, I mean, coming across in collaborations with Arup and other companies, I think we all agree that bio-based material is part of the future. It's not the only thing for the future, but it will play a significant part in the future. And in order to improve that, we need to learn from each other. And therefore, I think, yeah, this is a great event for that.
Perfect. And Carl, White Architect, what is that kind of a company?
We are based in originally from Sweden then, and lately we have been quite acknowledged for a tall timber project up in the north of Sweden called the Sara Cultural Center. It's a 20-story all timber building, and that is one of our projects, of course, that we are sort of trying to, we innovated quite a lot in that together with other partners, of course. And that is one thing in the bio-based area. And then I would say it's also for us important to think circularity. I mean, as said, bio-based is one important thing, but we also need to be good in thinking the circular approach. And that's why I also was so happy to see this thinking in some of those presentations of today.
Perfect. Thank you so much, Carl. We have to make the next presentation without a slide. So, Pretender, if you can, if we can get you back.
Yes, hello, hi, thanks, sure, Peter. Yeah, I'm happy to
And
share
you
this
have
out.
to just start your presentation now, and I will give you 5 minutes.
Sure, thank you so
Oh,
much, Peter.
sorry.
Uh,
I just heard that there will be access now for you for your slides. So give
yes,
me.
I do have access. Thank you
Okay.
so much.
I think it would be much nicer to get it on the screen
Is it
because
sharing?
it's quite novel.
Can you see the screen now?
Just a minute. So if we can start with just presenting yourself.
Yes, hello, hi, everyone. My name is Prantar Thamali. I'm a PhD scholar at the Advanced Center of Biochemical Engineering at University College London, and I'm the founder and director of TATFA, where we accelerate the carbon sequestering capacity of photosynthetic cyanobacteria to grow advanced living building materials.
Perfect. And we have your screen up now so everybody can see it. So please continue.
Great, thank you so much. So, cyanobacteria are Earth's oldest and first photosynthetic organisms, evolved 3.5 billion years ago and gave Earth the first oxygen-rich atmosphere that we live in today. Through an enzymatic process, they are able to sequester carbon dioxide that is dissolved in water in our seas and convert it into calcium carbonate minerals that bind natural sand together and create these living, natural growing rocks called stromatolites. But these stromatolites take thousands of years to grow because the bacteria grows one micro layer thickness at a time. At TATFA, we have adapted artificial tissue engineering techniques that are typically used for biomedical purposes like growing artificial organs and tissues to transform the growth behavior of these cyanobacteria species from a two-dimensional or unicellular form to a three-dimensional volumetric tissue that gives us a uniquely engineered living building material with very unique properties that we term as stromate. Stromate is lightweight and high strength, that it has a compressive strength of 3 megapascals. It has exceptional heat insulation capacity with a thermal conductivity of 0.03 watts per meter Kelvin and excellent fire safety equivalent to European A1 fire rating, but it has additional advanced biologic and regenerative properties. In 4 meter cubes of this material, we can directly sequester 1 ton of CO2 during the production process. And the cells remain alive within the material, so it can have active carbon removal that we are currently quantifying. It is also circular. We can take the material product back to the lab after its lifespan to trigger the growth of the cells and repurpose it to a new material after the lifespan. It has self-healing and programmable color properties that we are currently developing at the moment. There are three main application segments that we are developing at the moment. The most simplest is granular stromate that can be used as aggregates and sand for producing green concrete at scale that reduces the embodied carbon of concrete by 40%. It can be molded to make high performance insulation and fire resistant insulation for prefabricated building elements. And we can use it to design very innovative living photosynthetic, translucent, and insulative facade and cladding systems with this material. We have developed a new type of solid state photobioreactor that allows us to grow 1 meter size panels in less than 2 weeks' time. And this reactor can be scaled using the principles of vertical farming that we adopt for food and agricultural purposes. At the moment, we have partnership with Elston Farm in the UK to develop our first vertical farming pilot plant of this new material. We are a biotechnology company. We partner with existing building materials company to help them develop carbon sequestering product lines using our new process. Compared to all other existing biomaterials in the market today, TATFA is the only material technology that uses living photosynthetic organisms to make construction material. This means we are not just decarbonizing the industry, we are actively reversing the industry from a carbon emitting industry to a carbon sequestering one. It has versatile. We can use it in many different ways. It is circular and recyclable. And as you can see, it has a unique visual and aesthetic appeal that no other material in the world currently has today.
Just 1
We have
minute.
so far raised £865,000 in VC and grant funding, and we are currently looking for another £550,000 to establish our pilot plant, refine the technology, develop the products, and we are looking for partners in the building industry, architects, developers, engineering firms, and building materials companies to do pilot projects in the next 2 years. Thank you so much. If you're interested, please get in touch at pranter@tatva.bio. Thank you so much. I'm happy to answer your questions now.
Thank you so much. Really, really interesting. Should we give him a Tata a hand? And again, jury, a little bit exercise for you guys. And Serena, we will actually start with you. A few comments, reflections on what you have heard.
I mean, it sounds really impressive. I'm looking at your face down here. I don't know where to look. It sounds really impressive, and compared to other building materials that we see, this is obviously one that is carbon sequestration, which is, it's really impressive. One question I do have is, you obviously work at UCL and it's been developed through your time at UCL. Does UCL own the IP to this building material and your research?
Yeah, thank you so much. We have filed an initial IP on the first discovery of the solid state manufacturing process in collaboration with UCL, and we are actively looking at licensing that at the moment. But we have so far, since we have registered the company as an independent company in 2024 last year, we have so far developed 3 new IPs that is separate from that IP in terms of both product and manufacturing equipment, like the solid state reactor systems that are independently owned.
Great, thank you very much.
And then Morten, what is your thought to the presentation?
I would say it's a very exciting product. I haven't heard about it before I was presenting it in advance to this meeting. And you were mentioning you could put it into a vertical farm production system. How do you see the needed energy use for doing vertical farming? How would that affect your production and the sustainability of the product?
Thank you so much. So in traditional vertical farms where we produce food and agricultural products, the energy requirement is primarily in the use of light. But for this bacteria requires 100 times less light intensity than plants do. And most of my PhD research has been on the light efficiency of the product, and as well as in the design of the reactor that efficiently at low cost distributes light into the reactor system. And so we have currently the energy requirement for 1 meter cube, which is 1 ton of sequestration, is only 350 kilowatts per meter cube, which is actually half that of producing glass.
Any follow-up, Morten?
I was just you were mentioning locating in UK. Have you been looking to other countries with more renewable energy sources as well?
Yes, thank you so much. So currently our only plant in the UK, we have selected that place because of the renewable. It's fitted with solar and wind power. But our production model is, we are envisioning a distributed production model, so not centralized. So we want to have container-sized vertical farms producing this in various parts of the world, so that you can decrease cost in transportation of the material to the site as well, and use local energy.
Emil? What?
I'm speaking to this microphone. Very interesting. It's very sci-fi stuff here, which I like to hear about. I had 2 fairly practical questions. One, following up from Morten, you also asked about the energy intensivity. I was sort of wondering how labor intensive the production process is. So that's one question that I had, and to what extent it can be automated, that production process. And the other question I had is very practical. It's, to what extent are you able to mold and shape the stromatolite during the process?
Please, quick replies.
Yeah, sir, thank you so much. So in terms of the labor intensity, it is quite simple. However, it is not yet mechanized. We are actively working on that and in our current stage. So we are at TRL level 6. and that is on the mechanization of the plant is what we are working on. And in terms of moldability of the product as well, we have done some molds, but it requires essentially engineering of the reactor system. For depending on the product type, we would have to make a specific reactor design, which can be basically used to produce specific grown samples.
Okay, so right now you have one specific output, one specific shape, or?
Yes. But the basic process is similar for until it goes into the mold. So half part of the process is standardized, and then the final step of the shape of the product comes from a new type of reactor.
We just have 45 minutes left. So, 45 seconds. So Carl, I would just like to get your view on what you have heard. A quick observation.
Super interesting, of course, and I was very happy also hearing that it's beauty plays a role in this, because I think that is very important also when we are talking materials. I mean, beauty plays a significant role in making it also sustainable. People need to love those materials. I mean, they are shown. So was very happy hearing that.
Good. Thank you so much. Very good feedback, I think.
Thank you very much.
And then we have another on the side presentation from our good researchers from UCL, Tensolite. Please come down and we will bring your slide up. And you have come all the way from London. Thank you so much for your effort.
Very excited.
And I can see that you even have a small sample, really interesting. So give it a go, 5 minutes.
Yes. Good morning, everyone. I'm Ping, an architect, and this is Miranda, a biochemical engineer. Together, we are based in London, Tensol Bioworks, from Bartlett School of Architect at UCL. And we are presenting a Tensolite BPV, a living facade system powered by blue biomass. The challenge we are tackling is significant. The built environment is responsible for about 40% of global carbon dioxide emissions. Yet in our cities, millions of square meters of vertical surface area are currently underutilized, and with the potential to become productive. Our innovation employs synchronicities-based biophotovoltaics integrated into a tensile lightweight system. These BPV cells are configured in clusters and anchored on the post to the platforms for maintenance access, ensuring reliability and serviceability. Tensolite BPV capture carbon dioxide through photosynthesis while generating renewable energy from solar radiation. This system leverages ambient wind flow to agitate and aerate the growth of medium, maintaining optimal oxygen transfer without relying on the external pumps. All components are specified in recycled marine-grade materials, and cells are designed as removable cells to avoid full replacement. The electricity generated can directly support building functions such as lighting, heating, and environmental sensors. By addressing both operational and embodied emissions, the system reduces life cycle impacts and costs.
So our solution focuses on regenerative potential across the whole value chain through using circular materials with durability and replaceable hardware. To expand this lifespan, the lifespan of our products and minimize waste. We also can create local jobs, such as supporting the installation, the operation of Tensolite BPV, and also maintenance. In terms of our system, it also produces biomass as a byproduct that can be directly converted into biofertilizers, and later with production can be streamlined to food and pharmaceutical products for a diverse value chain option. Here is our business model, which is quite straightforward. We sell and deploy facade system supported by operational service for our biophotovoltaics. The prototype has been validated both through simulation and also on-site testing, for which proves the feasibility for pilot testing. And comparing to traditional facade system, this alleviates the water and the weight burden from the building support system comparing to the green wall, and also have an easier integration comparing to the building integrated photovoltaics. Our early market focuses on municipal buildings and sustainability-driven retrofits. With that, we hope to develop returns through reduced energy bills, carbon credit and savings, and also compliance with green building certification. Moving forward, we are seeking investments to accelerate our products to the market by scaling the manufacturing, conducting LCA, life cycle assessment, and also to fit in the ISO compliances. We're also looking for strategic partners, like some of you guys, to run our pilot testing in Nordic area, potentially, with all the resources that you have here and research. We hope to showcase our technology at scale. Together, we want to use Tensolite BPV to decarbonize the built environment. Thank you very much.
Thank you so much for your pitch. Please stay here on the stage. Our physical jury are coming up on the stage, but Carl, I would actually like to start with your feedback. This is a very architectural solution. So what do you think? Let me hear your observation.
Yeah, I can see many, options and where this could be definitely working. My first question is, do you have it in operation somewhere? Is it running somewhere?
We do have it running currently in London at our studio site, and also connecting to energy storage system that we have built. Yes.
That's a good start, I think. So, I really think, starting this in a small scale, in that sense, and to get something that really also is not only a test pilot, but actually in operation also on a commercial building would be very, very interesting to see.
And
Thank you.
I know that you will soon come to London, so perhaps a site visit to UCL. Emil, your view?
Yes, very interesting, and I was very happy to learn about biophotovoltaics, which was a new word for me. So it's always interesting to learn something new. I was thinking a bit about the picture that you showed on the second slide. I think it was where you sort of showed it installed on a building, so on the facade.
Yes.
Obviously, it's sort of in a prototype stage. Have you given any thought to sort of the ultimate design of this and sort of the aesthetics of this?
You mean about? Yeah, actually, we do some structural analysis to identify the configuration of how should we arrange those clusters. But definitely for now, we don't have the extra side. But yeah, we actually run some structural analysis about vertical configuration.
Yeah, I think at a later stage. Oh, sorry. Yeah.
Sorry.
No.
Just to add, we also have considered the weight of these modules hanging on the building itself, which is quite light. I cannot remember the numbers, but we have calculated.
Yeah. Actually, one module is under 3 kilograms, which is really light. And
how many kilograms?
3.
Okay.
Yeah.
Yeah, I think at a later stage, you'll probably have to sort of consider the design and sort of the aesthetic appearance of the system for it to be sort of successful in the market.
Yes,
Yeah.
yes.
Good. Thank you so much, Emil. Morten?
Yes, exciting product.
Thank you.
Great to hear about.
And I do appreciate that you take into consideration that we need our buildings not only to be buildings, but help us reduce the need to cut down more forest or nature to build more buildings to produce energy. So I think it's a great way of combining those two and thinking about the circularity of it, seeing what the waste product afterwards could be used for. Great idea as well. Have you tested that? Has it been through a biogas production method yet?
Do you mean by testing the biomass as a solution?
By trying to have it in a biogas plant where it could be turned into new fertilizer and energy?
We haven't yet, but that's part of our plan as a downstream process. As an initial purification of the biomass, we have achieved to get solid biomass, the dried ones, from 2 to 5 gram per individual cell units that we have designed. Yeah.
I was just thinking, you're working with producing energy. We have a big biogas industry in Denmark. If you could feed into that stream, that maybe would help you utilize more of the energy production in your product.
Indeed.
Perhaps with the progressive utility company at Bornholm, that's worth to note and follow up. Thank you so much, Morten. The last comment, Serena.
Hi. No, this sounds really exciting as well, to have like an interesting facade design. And I would emphasize as well what Emil said, that yeah, architects like to have their own like creative twist on things, so worth bearing that in mind going forward. One thing I did have, just 2 quick thoughts.
Yeah.
You mentioned maintenance and lifespan. How frequent is maintenance, and what is the lifespan of these? And a second quick thing was just around, it's enhanced by sunlight and wind. Are there like climates that you're looking that are more optimal for this type of facade design relative to others? Thanks.
I can answer a second one. You can go with the first one.
The first one, about the maintenance, actually we extract the data of the thermal condition on the full facade. We separate into small zone, and we do the machine learning driven process. So actually we define a season that we need to maintenance. So we don't need maintenance every month. Yeah.
And we have figured, we have done a in-house life cycle assessment, realizing that every season, around 3 to 4 months, it needs a exchange of the PV cells, biophotovoltaic cells, while the biomass harvesting can happen over a month. Yeah. The second question, sorry. Okay. Sounds good.
I think we have to close off this pitch. Thank you so much for you. Thank you. And the next presenter will be online, coming from a little bit outside Aarhus in Denmark. Henrik Thulsen, are you online? Yeah, I can see you.
Yes. Can you hear me?
We can also hear you.
That's a good start.
Thank you. And then we should have your slide deck, and we have it here. So, Henrik, I will give you 5 minutes, and the floors are yours.
Yes. Before I start, I should apologize to the people waiting in the lobby. I had some trouble with my microphone, but I believe it's working now. Yes, my name is Henrik Thulsen, and I am the CEO of Dansk Algeplast. A journey that started 5 years ago. I'm actually an electronic engineer, and I had an assignment working on a electronic cabinet, where this whole journey started with a conversation I had with the plastic engineer who was in charge of creating the plastic we needed for the electronics. And he told me that bioplastics is actually an older invention than fossil-based plastics, which was interesting to me, and explained me a little bit of the dilemma that those technologies face, as they're usually based on corn or potatoes or sugar starch. So I started to alter some old techniques used in the Second World War from Henry Ford, and created a new technique, a way of producing bioplastics That's 100% based on seaweed instead of corn and starches. Last year, I was so lucky to win the competition of the Climate Entrepreneur of the Year, which has given me some attention, and a lot of companies have started to reach out to me and even donated me the production equipment that I'm currently using, even though I explained them that I am going to rebuild it a little bit. So I have a couple of injection molders and extruders from Primoplast, where all the electronics currently looks like a bird's nest. Basically, we create bioplastic that consists of 100% seaweed-based polymers. That means that we don't add any additional ingredients, no fossil-based polymers or anything like that. The bioplastic itself is 46% carbon, which means if you calculate 1 kilo of bioplastic, it binds 1.67 kilos of CO2. So depending on how you get rid of this material, it has the potential to be CO2 negative. Of course, if somebody lights it on fire, that whole calculation goes to waste, but it has the potential to be CO2 negative. Currently, it's ideal for indoor applications and sustainable design. It has a very low energy production process, as it's an altered existing process, and it's a bit more simple in many ways. It sucks a lot of excess nitrogen out of the water that it's currently the seaweed itself is grown in. As Peter explained, a lot of municipalities in Denmark has seen the last the CBR numbers of local fishermen shut down, and a lot of municipalities with a strong tradition of fishing don't even have a single fishing boat left in it, and that's really sad. Yeah, the seaweed used consists of between 3 and 5% pure nitrogen, and have shown the potential to grow with a daily rate of 22%. This is not every day. These are the best possible days, and there's only a few of them per year, but it still shows that it generally grows faster than anything you can grow on Earth. And you obviously don't need to water seaweed. And it can create jobs for the fishermen in these municipalities. The business model is fairly simple. We want to produce and sell plastics made from this seaweed with a biodegradable material, which is, when you're talking about plastic, not always a good thing, which is the reason why we are actually looking at the wood market about as much as the plastic market. There's a lot of traditional usages within plastics today where this material would not be a good fit. But there's also a lot of segments where it would be a good fit. That's because plastic is often sold because it's not biodegradable. Yeah, we are looking for either opportunities to validate the product in the market or looking for investments. Yeah, and we want to start off by producing something simple like boards or panels. We can do complex shapes, but it's a bit more difficult. And I know that I'm going to be the one standing next to the injection molder or the extruder. So the less trouble I can have as a start, the better I think this can take off. That should be 5 minutes exactly, according to my watch.
And Henrik, he have given me actually a sample that I will share with the jury, so you can feel it. It's precisely the same as he showed on the slide deck.
Yeah.
Serena, I will start with you. What do you see? What potential do you see in this?
Well, I definitely think. Is this working? Oh yeah, it's working. Sorry. It seems like this is it quite a durable material? I'd be interested to understand a little bit more about like the properties and whether you'd be seeking like ISO like accreditation and standardization in the future. But yeah, no, sounds like a great product, and I think it's quite aesthetic. So.
Yeah. Yes, I have to remember what this number is, but essentially it's what is it called? It's more or less impossible to tear apart, but you can crack it about as easy as you can with fossil-based plastic, and it's not flexible. But it can only expand about 2%, which is different than a fossil-based plastic. But tensile strength is the word I'm looking for. The tensile strength is about 5 times as high as fossil-based plastic. So the dog bone that Peter has, it would require 1.3 tons to tear that apart, but you can crack it with your fingers if you want to. But that's much like wood, actually. Wood acts the same way. It's impossible to stick apart, but you can crack it. Yeah, sorry.
And very quickly on the flammable properties, you mentioned if someone set it on fire, it might, what's the flammable properties like?
Yes, we've tested it at Technological Institute as according to the building standard, and it does pass, but it like barely passes.
Okay.
So it's better than wood in terms of that. Yeah.
Brilliant.
Thank you, Henrik.
Thank you.
Carl, have you seen such a product before? The bio-based plastic, the polymer. What do you think about it?
No.
Yeah.
I must admit I have not, what I recall at least, but of course, I mean, just hearing, I mean, of the huge potential of the speeding, growing seaweed in the water, and of course, I mean, it seems obvious that this is something that can make a big difference, of course, to get rid of the fossil plastic there. The challenges ahead, though, I mean, you said that, I mean, so far it's not for any more complex design or forms like that. And why is that? Is that because of the materials, how it's working, or is it more because of there's not the equipment to make those more advanced design?
I'm trying to answer in a simple way, but essentially the hardening of the material is different than anything we know in the industry. So I do have some ideas on how to compensate for this, and we have built some machines that can compensate for it, but we need, my neighbor is a smith, and he really helped me build a lot of, like everything is custom made, and we can prove that it works, but it's so manual. It's so difficult to automize. But with our hands, we can make it work, but we don't have the machine that can automate it right now.
It
But
sounds
it's essentially
expensive
because,
still.
yeah, it's expensive, but it's also difficult. But yeah, it's the hardening essentially, because it deforms during the hardening process in a way that you need to compensate for as you're cooling it down. And it's just, yeah, it acts super odd compared
Perfect.
to, yeah.
Good.
Okay, thanks.
One last comment from you, Emil.
Yeah, it's interesting. I think I mentioned in my sort of opening speech there that we've supported various projects dealing with using seaweed as a construction material, including one dealing with using seaweed to produce bioplastics. The problem that they had was they tried to 3D print things with the material that they had and couldn't get the right composition. It just became too brittle and it just broke apart. So I'd be interested to see how you sort of get around that. I mean, it seems fairly robust, the thing that I've got in my hand here now. But yeah, I'd be interested to see sort of how to do that and how to do that at scale as well, because I think that sounds like your challenge as well.
Super quick, Henrik. We're running out of time.
Yeah, basically I've heard a lot of other vendors talk about brittleness, and I don't understand why that's an issue. I think they're doing something different than me, because I don't really think I have that problem.
Good. I think that just needs to lead to more conversation between Nordic Innovation and Dansk Elgeplads.
Yeah, sure.
Thank you so much, Henrik. And then we have Bjarne, a new, another Dane presenting. Bjarne Hammer from Studio Hammer have traveled all the way from Frederiksberg It's great pleasure to have you here in Stockholm, Bjarne. Of course, with your wife. It's good to see local support. Yes. And I can see that you have taken some samples with you. Should I hold them? Perfect.
You could do that. Yes.
Okay, good. And you have the floor. 5 minutes is yours.
Thank you very much. Thank you for opening my presentation, Peter. My name is, how do I shift?
Sorry.
And this one?
The big one.
My name is Bjarne Hammer. I'm an architect, co-founder of Smith-Hammer & Lasken Architects with offices in Copenhagen and Shanghai. In 2022, I founded my own studio, Studio Hammer, focusing on doing climate responsible solution, targeting the building industry. Today's project is called MOOM. MOOM stands for Made Out of Muscles, and it has been carried out in close collaboration with Baltic Blue and Baltic Shells. Well, the building industry needs climate responsible materials. That is why we're here today. Using mussels, the shells from mussels, is pretty interesting. I mean, it's a leftover from the food industry, and you'll find it in enormous amounts. So what you use shells for mostly today is for landfill. Using the shells in MOOM products, it means that it's an upcycling. Is there a demand? Yes, we know from the industry talking about architects, designers, developers, that they are seeking to a bigger extent to have natural and bio materials available. And we also have the building codes. Many countries have restrictions due to which amount of CO2 you use in your product, in your materials, and also have restrictions to give accounting to have building permission for CO2 per square meter. So demand is clearly in a position. It's worth to note that the EU has a framework directive around water, and they recommend that more cultivation of mussels to clean the water, but also to make climate optimizations. Shells are binding CO2 to a very big amount, it's also interesting to understand that the shells withstands fire up to something like 1,000 degrees. If we have a production of, for instance, 300,000 tons of mussels, there will be 200,000 tons of shells, and there will be something like 100,000 tons CO2 you can bind in a product. And also interesting that mussels cultivation don't have any need of feeding or medication. The process of doing this material is that you have to clean the mussels for salmonella, then you cross them in different fractions, and then there are two possibilities, version 1 and version 2, where you bind it with either recycled plastic bottles or with a biobinder. And of course, using the biobinder, it means that you have a material that you can have as waste in the nature. And after a mixing process, you mold on a high pressure to what product you actually want to have. Recently, we did a test production to see the market response of the material. It was a small project. It was a door handle. But the response was pretty positive. I mean, this is 90% mussel shells, 10% of binder. The product, it was done for Randi and EcoShelter in Germany, and the product received several design awards and innovation awards. So it gives a belief that the market is positive, or also to trust the material, and the product also fulfills a number of DIN norms. We have asked Danish trade offices around to register how many mussel shells are available. Enormous amounts. In Denmark alone, we have 15,000 tons available right now. Eiffel Tower used 7,000 tons of steel, so we have actually a production option of 2 to 3 Eiffel Towers per year. We have a market plan or a business plan where products related to the building sector or to lifestyle sector is possible to do. Where are we now? We have a status where we are seeking to set up a production facility. We have a trademark registration. We have IT, European IT patent pending. Production facilities under planning and validation of physical and fire certifications is ongoing, and we have dialogue with the market with possible customers. So we are kindly asking for your support and interest in investments for further development and setting up a production facility. We need to create change. Thank you very much.
Thank you so much for this this selection of product. The jury come up and feel what Bjarne have designed.
Feel, hear, and smell.
And Bjarne, if you can come closer to me, so we have space for also for Morten. And Morten, will you start?
Yes. Bjarne, thank you for the presentation, and I'm very pleased that you're doing this. But because I did my master's in environmental planning, evolving around blue mussels, so I'm very happy to see that you're working with this kind of product. You say you use it off the food side streams, off streams. Is there any problem with contamination in using those off streams? Is there too many different other materials when you get the blue mussels? Is it washed before you get it? Is there a cleaning process before you start working with it?
Process. Of course, you clean it with water on a high pressure. Then you take it to a high temperature to move the salmonella, something like 80 degrees or something like then likely. And then it's ready for the production.
And how does this process affect the carbon footprint of your product?
Of course, we have to see a total line of everything, ESG calculation. And we haven't done that so far, but I mean, the temperature is not that high. We have windmills, so all the power we need is green power.
Could you maybe source the product from a different stream than food waste?
It might be possible, yes.
Let's talk about that more after the pitch. Emil, reflections?
I was also wondering about sort of the getting it from the waste streams and whether you have any plans to do like around primary production or finding other streams for the actual resources that you're using. But you've answered that already. Another thing that I was wondering is, so you're making this a composite material from mussel shells and recycled plastics. And then you say that this is sort of recyclable. When the material is recycled, can it be separated back into its constituent parts, or are you sort of locked into your loop?
I mean, the version 1 is recycled plastic. The version 2 is a natural biobinder, where you can also add a fire protection or antibacterial effect. But talking about the recycling is a take-back system, where you just crush the product again, and then you take it to a new generation in the mixing process. So it's recyclable. And I mean, having bioplastic as a binder, there's nothing to separate because it will leave itself in nature.
Good. Carl, quick one. We are a little bit over time, so just one quick comment to Bjarne, if any.
Yeah, amazing project, and what I really like is, of course, that it's there are so many ways to use this material. I mean, as you say, it's in the actual design aspects on as this door handle you said, but also for bigger products in the building industry, construction industry, for instance. So I think that's a huge potential, and Yeah, and so hopefully also it can stay all bio-based, so it's go circular there. Thank you.
Thank you so much, Bjarne. Amazing. We have to take the last presentation because we are a little bit out of time. So, Jury, do you mind to help Bjarne carrying his material back?
No problem. Thank you.
Thank you so much. And the last presentation is Utah, Studio Utah. Another from UCL. Basil, Kayan, can you hear us, Robin?
Yeah, thank you so much.
Yes, we can. Can you see the screen okay?
And we will get the screen up shortly, but I will suggest that you just start to introduce yourself and the slide deck will come in 10 seconds. Right, Joachim?
Amazing, thanks.
I will press the
Hello,
time now,
everyone.
so 5 minutes is running.
Good afternoon, everyone. We're Studio Utah, an interdisciplinary design studio based in London. We met during our master's at UCL, where we began combining biochemistry, engineering, and architectural design to explore the future of regenerative materials. So I'm Robin. I have a background in civil and environmental engineering, and we also have Kian with us, with a background in bioprocessing, and Basil, who's trained in architecture. So together, we've developed a novel biomaterial and a biofabrication that harnesses blue biomass, specifically chitosan, a biopolymer derived from shrimp shell waste, using enzymes as biological catalysts to bind and shape in ambient conditions. So is the slide deck up on the screen?
It should be. I'm sharing my screen. Is it not visible?
Yeah, just give us a minute. We will.
Okay.
I've made the most difficult job for Joachim at the whole World Water Week. Now I can see it, so please continue.
Amazing.
You can see us posing with our latest prototype on the picture of the deck. As we know, the built environment depends heavily on plastic-based materials. And rarely recyclable, energy intensive to produce, and persist for decades in landfill. On the flip side, most biomaterials like real construction work. This creates what we identified as a midlife material gap. We need materials that can perform for years and not a couple of months or centuries. Zume, a tunable regenerative composite made using upcycled blue biomass, primarily chitosan. And what's powerful about Zume isn't just the material, it is the process. We developed an enzyme-based curing system that works at room temperature using no toxic chemicals and very little energy. So here are a few samples of binder giving a new life to sawdust waste. And here is like a robotically extruded sheet, and you can see how the board material can be. And here is an example of an early sample where we use a robotic extrusion to create complex and intricate geometries.
So the tunability and longevity of Zume position it for a range of applications in the built environment. Chitosan, derived from blue biomass, forms the backbone of our composites, imparting both strength and lightness into each prototype. Enzyme integration and robotic extrusion then yield high-performance, customizable prototypes with smooth, sleek finishes as seen here. These make our composites viable plastic alternatives in interior architecture and product design. Zume can also act as a binder, transforming textile waste, sawdust, and construction byproducts into durable, versatile composites. It serves as a non-toxic resin alternative capable of reducing the life cycle impact of traditional construction materials such as MDF or chipboard, and providing a more sustainable pathway for material fabrication.
So we're building a material platform starting with Zume as a flagship product to upcycle blue biomass. We plan to have two revenue streams. The first, a B2C design service offering bespoke interior solutions and installations And then a B2B biodiesel, which we plan to supply directly to manufacturers, for example, those producing engineered wood products. And this product emerged from a real industry problem. It's not just us trying to push our solution. A composite manufacturer, Fabrico, approached us to create a substitute for the resin that they're using in their upcycled waste textile composites. So we're developing a solution together as a first client. But it's not an isolated problem. The adhesives are a $73 billion industry, with bioadhesives comprising 6% of that market value and growing at 9% compound annual growth rate, outpacing normal adhesives. We're also partnering with Essence, who have over 10 years of biocomposites, to help us as a strategic technical partner and our go-to-market strategy. In order to get our materials that harness blue biomass to market so they can have the impact, they can have impact, and to start generating revenue, we're seeking 76,000 euros in seed funding to support critical development and scaling. We have our first demonstrators already in place. We can see our fabrication process on the left. We're around TRL level 2 or 3. I think more importantly, we want to work with partners in architecture, engineering, as well as investors to realize a world where we can design with less. Carl, we hear you're a big believer in products like ours. We'd love to work together. Carmen and Björn, also, it'd be great to see what kind of solutions we can come up together and really build on harness blue biomass. Along with ISO certification, we're also looking to secure or complete LCAs to ratify the performance of a material. And thank you. At Studio Uta, we believe in growing materials that serve and then disappear.
This is the last pitch. Jury, come up here. Carl, let's start with you. We will have two comments for our jury, and we will start with you, Carl. Very impressive, right?
Yes, sure. And yeah, I will visit you also in London when there, of course. It would be real fun. And for me, this is still, more unexplored for me than some of the previous we saw here. So really thrilled to learn more about it, and I have So I leave it for the rest of the jury to comment, please.
Thank you, Serena.
Yeah, no, it sounds like the designs that you're able to create are like very intricate and seems very customizable to whatever needs your clients or consumers might have. Are you using 3D printing to be able to do this? Is that how you're using it, or is it more woven? What's the technique?
So currently, we started off with sort of 3D printing, extrusion, and maybe Robin, you want to speak to this a bit more, but we also can do molding, and we're exploring injection molding too. So we're not really wedded to extrusion technologies. We're just looking to sort of scale and get our solutions to market, but primarily, yes, for the design solutions, we're looking to specialize with extrusion technologies.
And
yeah, we went into 3D printing at the start.
Sorry,
our idea was...
Robin, we will just have Emil to give you a comment.
Yeah, just really quickly, I was wondering about the possible functions or functional benefits of this material. So would it provide things like soundproofing or UV filtering or rain cover or carbon sequestration? Can you say something about that? Have you looked into it?
I think that one of the pros of this material is that it is quite customizable. It is certainly aesthetic. We're looking at it as a shading device. But I think as well as we explore this idea of it being combined with more aggregates, it has the potential to serve as insulating or acoustic barrier. And so we're really diving into the breadth of applications it can have, but the short answer is that it is tunable, and we believe that it could have a multitude of purposes.
Thank you, Basil. Thank you, jury. So the process now, we have 2 minutes left. So our very dynamic jury, they have promised that they can take a decision on the top 3 solutions. So if you go into the corner and agree on the issue, then I will say to all of you who have presented that I would actually like to invite you and your product to be exposed at ARUP the 26th of September at our headquarters in London, where we are trying to gather an exhibition of blue biomass. We'll also we will invite around 200 participants to discuss the topic of blue biomass. And as you can hear, then I've teamed up with Carl, and I'm trying to convince him to come with London to me with a lot of other guests. So this is not a one-off. This is really us being inspired by you, and I really would ask everybody to applaud for all the solution providers which have given some really inspiring and very innovative solutions. Thank you so much. I've really been entertained and impressed about your presentation. Thank you. Again, ARUP are doing a national roadmap on blue biomass, and in that roadmap we will present a lot of the product from around the world. That publication will go global in February, and I really hope that all the 6 solution providers which we have selected here in our accelerator program would we can discuss it later, but I hope that we can actually use some of your illustrations, some of your cases in our publication. We will discuss that further. In ARUP, we really work in partnership, and we know that we are just one of the actors in the field. We need the investors, we need the supply chain, we need the industry, but we are big enough that we can actually manage to gather these actors together to push such an important agenda that we have talked about today. So please let us connect. This is just the first step of the journey. Don't be disappointed if you're not a part of the top 3. We will be able to nurse your product further in the process and make it sure that it will come closer to the market, hopefully be implemented and scaled out. Jury, are you ready to announce number 3?
We will let Serena present the winners.
Okay. No, thank you very much, everyone. They were all really inspiring, and I think together each of them could be deployed maybe by Nordic Innovation in a test housing project, each having their own role to play in the building. So we have got 3 that we are really excited about, or the most excited about, and think have the greatest potential at this moment in time. But I have to say that each of them have great potential in themselves, and I think I personally will be taking them away to the materials team that we work really closely with, and they have a materials accelerator program of low construction materials, where each of these I definitely see having a role to play. But without further ado, the top 3 that we have, in no specific order, we've got TATFA, we've got Mineral Fox, and Tensolite BPV. So thank you very much, everyone. Let's give them a round of applause, as we already do.
Thank you so much, jury. Congratulations to all of you. All of you have been selected and presented here. I will have to go back to ARUP and figure out how we make a plan for moving forward with all of your solutions, but we will have prioritizing the 3 top candidates that we have selected. But I also want to make a big applause to you, Joachim. I guess that this has been the most challenging session in World Water Week. I do apologize. Thank you. I think we could give Joachim and the World Water Week team a hand. Thank you. So this was our first Baltic Blue Accelerator. Take a look at Nordic Innovation's program on ocean economy. Keep in touch with Morten and the hackathon. This is open invitation for you and for the community around you, and I really hope that we can collaborate much further in the future. Thank you so much.
It gets hard to know what he's thinking.